And then we can continue from last week. So basically, just to recap again what we did last time. We looked at the application of differentiation. We looked at your average and marginal functions. We looked at how when we get information from a total revenue or total cost function, how to work out marginal revenue and marginal cost, and then also how to work out your average revenue and average cost. So that's what we covered last time. Again, I will share some of those recordings on our WhatsApp group as well. So as let me just quickly pause. There is a form to complete for attendance, but let me also put in for the guys that will watch this later, also the link to the WhatsApp group, and then I will also just add my cell phone number also if you want to join the WhatsApp group. So and I'll normally share all the things that we discuss in the session, and then obviously when we come to exam time, please share your questions. If you have certain questions that you worked through that you want us to look as a group together. Also, while I'm just talking about all the admin stuff, please also just send me again your exam date. At the moment, I've got it as the 28th of October. But if there was a change in that, please just put it in the chat. Okay, so going to what we did again last time, we went through a few examples of a marginal cost functions. Then we went into the average revenues. We went into when we looked at production functions, and then specifically around labor cost and those kind of things. And then we nearly ended off with a few of those examples. Okay, so today, and also what we went into is some of the elasticity of a nonlinear function. We worked out one example of that as well. So basically, last week we covered study unit 6, and yes, I will reshare that session that we had. Today we're starting with integration. So basically, and again, you can see we did some work last week on integration, but I just want again quickly to recap one or two things around integration. So basically, integration is the opposite of differentiation. So integration is the reverse of differentiation. So there is a nice diagram in your study guides as well around the process of differentiation and integration. So basically, again, when we differentiate, there's certain rules that we need to adhere to. So like in differentiation, with integration, we've got the power rule. The other one that we have is when we do substitution, just like we did in differentiation, we substitute a function with u, and then we integrate the so-called easier function. So very similar to what we did in differentiation. The one thing you guys must just remember with all the work we do in integration, um, we will always add this extra C because we don't know if in the original formula there was any constant. So we don't know if in the original there was a plus 6 or plus 8 or plus 10. And when we would have differentiated it, remember, when we differentiate a constant, it falls away. So that's why we will, in all the integration formulas, we will put in plus C just as a placeholder for the possibility that there could have been a constant that we have nearly dealt with. So you will see in a lot of your answer sets when we work with integration that most of all of your answers will have the formula that they integrated plus C. And normally if there isn't a plus C, you can nearly exclude that option. So, but I will go through a few of that for exam prep later that we can look at that. So I thought again, okay, but let's just recap some of the work. We do another few examples of integration before we go into some of the consumer surplus and those kind of things that we also need to look at. So again, let's look at this. What I thought, yes, we've got all the answers, but nearly write down what you would have done. Just jot down one or two things. So you don't need to work through the whole thing that we will do now, but nearly look at it. Look at the term below. What would we do with that? And just jot down two or three things that you would do with an example like this. Okay, so when we have an example like this, there's again, when I look at this, I look at the bottom one and I'm like, ugh, okay, we're dealing with two terms here. So I would rather rewrite it and say, well, let's substitute. Let's substitute that 2x minus 1 with a u. And again, you can substitute it with anything. So you can call it k in whatever. It doesn't need to be u. But then nearly we need to remember, okay, what's the other things that we need to do? So back doing the integration, we need to know, okay, so we need to integrate this function, and we need to integrate this function. So if you look at what we need to do, the first function to to look at is with 2x minus 1. And if you look at what 2x minus 1 does, remember there's a 1. We will take that to the front. 1 minus 1. So when we differentiate that first one, we will get 2. When we look at this component, 10 over mean. So what I would have done with this is a bit different. So when you look at this, I don't like to work with a fraction. Sorry, I'm stumbling over my words this morning. I wouldn't have wanted to work with a fraction, but again, if you see what they did, they were happy to work with a fraction. I would have probably wanted to make it 10 minus 1. That is if I worked with it, but again, you guys can decide which one is easier for you to work with, because in the end, one will need to put it back as one of the functions as well. So very important, nearly in a lot of these questions, what you are most comfortable with. So please, if and I'll quickly go into another example as well. So if you look at this example, again, we have a 2-term underneath a square root. So again, I would have isolated that as a 3x plus 4, and then if you do that, you can as well change it to a half. So again, you can see, depending on what you need to do, you can change it into a few formats. Again, for me, very difficult to work with that, because I really don't know if I need to integrate that, what nearly is the next step. But it's easier if you need to integrate that, to say, well, when I integrate, remember, I need to add 1 to that. So then it's easier to say, I add 1 over 1, so that we get 3 over 2 divided by 3 over 2. So that is, again, easier to work with for me than to work with a square root, because honestly, when I look at the square root, I'm like, I don't really know where I need to go from there. But it's easy to know where to go from if you have something to the power of a half. So just things like that, very important to note. So again, if it was to the power of 3, it would have been something like 1 over 3. So just remember those small things that really does make a big difference in how we calculate some of these questions and answers. So let me quickly go to another one just to show, and I will share the pack again on WhatsApp. So, but most of it is in your study guides as well. So that's, I want to check if there's one with okay, so again, when we look at this one, we've got x plus 1 over your bracket, so that we can again make something like u. Then obviously it would have been u to a power of a half, and then here you can again see here they worked it out with that. So again, would have been very difficult again to work with a square root. So please, if you get things like a square root, cubic root, they might be weird. They might even do this, so that you just remember to make it. So if it was u 1/5. So just that for me is nearly the important thing out of all of these, is to please transform it into something that you really, it's easier to work with. What will also happen, and again, it's more to say, look at your final answers, because if you look now at this, so this is also actually a final answer. So let the answers guide you nearly to what level you need to simplify, because this for me is actually okay. But again, it might be that in your exam, they're writing everything back into the squares. So again, just watch out. Even in some of the assignments, you guys can go back and look at some of those assignments and see at what level did they stop. And again, it just saves you time. So if the second last row is the final answer sets nearly, then don't simplify further. But if all your answer sets in your question have square roots in it, then it's nearly okay. I need to take it one further step. So please again, before you nearly get to that final answer, just check what all your answers are, because I know, I've seen in previous papers, sometimes they stop at this point, but sometimes they also go to the last, that you nearly need to put it back into the original format. Okay, but again, that can save you a few minutes as well in the exam. Then the other one I also wanted to show is when there's something at the when we nearly have two terms, and there's one at the bottom that has a negative term into it as well. So again, when we do this, we will make that 5 minus 8y. Again, let's just make it u. Again, you can do anything with it. So when we differentiate that, remember, like we said previously, c will disappear. We will basically sit with -8. And then we need to work with integration. So with integration, we will have that function, and remember, divided by 8. So we will have that. So we can, again, at any stage, rewrite that. So when we, again, easier what I would have done is to start eliminating. So I would have at this stage already done that, so that we nearly have it at that stage, because you can automatically start doing that. But again, what is the simplest for you guys? So if you wanted to isolate that term first and then work with the rest, that is also fine. Then remember, if we have this and we need to differentiate that, remember what chapter was that? I think chapter 3 or 4, where we looked at that. So something divided by u, remember that becomes ln of u. What we also need to remember is, and the reason why they put in the absolute value sign is because that needs to be positive. So again, it's small things that are added that might make a difference in your final answer set, because again, so we will now substitute that, but you could have had in your answer set, instead of the absolute sign, you can add normal brackets. So it could have been that one of your answer sets is with normal brackets and one of your answer sets is with the absolute value. So just if you guys haven't come across, okay, sorry, that needs to be, so if you haven't come across this sign, what it basically means is absolute value, and whatever is in this between those two will become a positive. So even if it is -6, your end answer will be +6. So there's a difference in these two, and we need to remember that we need to write it with the absolute sign. So very important when you do that. I don't know if it was in any of the others. See, so there wasn't in any of the others, any of those. So again, just be very careful with this one, so that when you have something like that, that it needs to be positive. I just want to check something on the calculator, and for the reason why. Okay, so you guys can also check on the calculator, but you can't. So check if you have a ln that's negative, if you can actually get an answer for that. So that is why that always needs to be positive, because you can't work with a negative ln. Okay, so it will always give you an error if you look at a negative ln. So or negative log. So when that's why they nearly force that to be positive, because you can't have a negative log. Okay. So that is the important one out of this that I wanted to show you guys. So just remember, when you're working with logs or with Lin in the integration part, you can't have a negative log. So please remember to put those two straight lines next to it. It means absolute value, which makes it positive. Okay, so then the next part is so we will look at what they call, when we integrate and the values or the area under a curve. But the reason why we do that is in actual fact to to get to what we know as, and we did it in, I think, in chapter 4, with when we had the linear functions. So we start to look at and sorry, let's just start from the top. So where we look at when you need to look at the difference in this small area, what the area is, what the top part of the area is. It was, if I can remember, what was it? Total cost, not total cost. I'll get to the name now. It has now totally went out of my mind, but we would have looked at this component and that component when we add the okay, it's totally out of my mind now. I'll remember it now. Okay, so what we do when we how to solve this is we will need to define the integral. We will then need to work out the formula, and what we will then need to do is, when we integrate, we will say there is two values that we're going to replace into the integral. So in this instance, the two values was 5 and 1. So we will integrate this, and then we will say, okay, but let's work out what the area is between 1 and 5. So when we integrated this, we will substitute the 5 into it, and we will substitute the 1 into it, and we will subtract the 2. So that is the process that we're going to follow. So let's just move those two around. So first we need to integrate. So if we look at this formula, and this is one of the more straightforward ones, integrate. So remember, we say plus 1, and then we divide by 3. There was a 1, so we say plus 1, so it becomes 2 divided by 2. Here we add the x1, going to divide by 1, so it's not going to make a difference. We're going to add a c, but because okay, so let me show you. The c will disappear in the end, but let's quickly just rewrite this so that you can see what I mean with that. So the 2 and 2 disappear or cancels 1 out, so it's minus x to the power of 3, or the power of 2, 3x plus C. Okay, so now for this, we're gonna add your values 5 and 1. Okay, so we're first gonna put in 5 into the x's, and let's continue here. So 5 to the power of 3 divided by 3 minus 5 to the power of 2 plus 3 to the power, or 3 times 5. Okay, so now you would see that I've got the C, but this is references to X. So the C will just be there. So you actually do nothing with that. So that was the first component, and then you subtract where you substitute with 1. So 1 to the power of 3 divided by 3 minus 1 to the power of 2 plus 3 times 1, again plus C. So what will happen is, in actual fact, you will see your C and C you will subtract it. So again, I would have, in this instance, I would have stopped with C. You, in the exam, you guys are, nobody's looking at your answer set, or how you worked it out. It's multiple choice, so the lecturer or even the computer only marks or mark what you have chosen. So again, I would probably have left the C out at the beginning, just that it's one step less. So again, you guys can decide when you need to work out the areas between 2 points, if you want to include the C, if you want to exclude it. In the process, it will cancel out in any case. So again, when you practice, when you go through, it's all up to you to see, does it make sense if I cancel it out earlier, or do I want to carry it straight through? But at some stage, it will fall away. So again, you guys can nearly decide at what stage you would want to do that. Okay, so when we work out this area, they need to tell you that we want to work between the points 5 and 1. There's because that influence whatever the answer is going to be. So they need to give you at least somewhere in the question the reference what you need to use. They can't keep it open and say you work out the area underneath the graph, but they don't give you information about it. So the same with this one was they gave us the graph, and then they say, okay, you need to work out the area between 0 or 2 and 0. Okay, so the same principle will follow in that instance, that you will also work with the same, so it will become x3 over 3 minus x, if I am correct. So you will see that is how you will work. But the difference with this one is, and you could see it here as well, you will first need to work out that component, and then you will need to, so you will first need to work it out between 2 and 1, and then you would need to work it out between 1 and 0. Okay, and the reason why is if I automatically set between 2 and 0, I'm actually working out a different area. Okay, so then I would have worked out, sorry, let me now make it exactly what I would have worked out. So if I said, let's work it out between 2 and 0, this would have been the area in red that I would have worked out. Okay, so, and that is not the area we want. We want the blue and the purple area, or if that is purple. So we would need to work out first your area between 2 and 1, and then the area between 1 and 0. Okay, else we are definitely working out the wrong extra area, and your answer will definitely be different, because you can see the area between 0 and 2 that I will add is much bigger than the other area. Okay, and you can, again, I will share this so that you can also go through this example, so that you can see how it is done. Okay, then another one that I thought was good for you guys to see is there's some, and again, so those first two graphs, easy, you can, or not easy, but you can visually see it. Then they can give you a graph like this. So, and when I look at this, I'm like, ugh, I can't even think how I would have drawn that curve. But it is an exponential graph, but that is nearly it. I really can't visualize this at all unless you put it into a online calculator or something, and it draws it for you, which might be nice if you guys do it for practice and those kind of things, that one can just have nearly a view on how something like this actually looks like. But now you see they tell us we need to define or get between the values of 2 and 0. Okay, so at least they tell us we need to work between the values of 2 and 0. Okay, so now we need to first go and remember, okay, now we need to integrate this. Now, again, it's not as simple as some of the previous ones, because we now again sit with this thing called exponential function. So once again, we will nearly tweak it a bit. So we will say, okay, I'm working with two terms, so let me change the 2x plus 3, or sorry, minus 3 to u again, so that we can work with that. So then you will see when we look at that function, and remember from what you guys did in chapter 3 or 4, might be 5, when we look at e to the power of something, that will stay the same. but now remember we sit with the 2x that would have been 2. So the one thing happening here is that we will divide that by 2. But remember, the key thing is when we look at the differentiation and the integration, and specifically again, if you look at exponential, it stays the same. So the only thing that then is when we look at the du dx of that 2x, so it becomes the 2. So 40 divided by 2 is 20. So we will then sit with this one, that we will change the u again. So we will substitute the u back. And now we will need to replace the x by 2, work it out, substitute the x by 0, work it out again. I nearly removed the c because you will have a c in the first one, you have a c in the second one, and as you work it out, the c's will cancel out. But let's quickly just rewrite this formula for you guys. So 2 times 2 is 4. 4 minus 3 is 1. So that will be the one part. Then we have 20e. 2 times 0 is 0. So 0 minus 3 is minus 3. Okay, and now you guys can see what they did was to bring out the 20. You don't need to do that. So you could have worked out that answer. So e to the power, e to the power of 1 is 2.7, and it continues. So that times 20 would have been 45. Dyslexics I am now, it's 54. And then e to the power of minus 3 would have been 0.049. So if I times that by 20, I get that I need to subtract by 0.9957. If I add those two, or if I say 54.36 minus that, I do get the same answer, 53.37. Okay, so again, you didn't need to isolate the 20 and then work it out. You could have calculated that. You could have calculated that, subtract the 2, and you will get the same answer. So just again, look at what's the easiest for you guys to work with, so that if you prefer to do it this way, do it that way. If you prefer to work it out automatically, do it that way. Again, I think there is options, so just what is the easiest for you guys. Okay, so that was another example of just finding the area under the curve. So I'm gonna skip this one, but here's another one that you can go and look at. I think if you nearly cover a normal one with exponential, and one with a a len or log function in it, you guys will be fine, because that is nearly what they can ask you. So it won't be other weird functions. It will be exponential log or a normal function when you guys are working with this. Again, what I would have probably done is to just check again how this function looks like. So again, there is online. Let me quickly check if there's not a nice online tool that I'm just checking if there is a graph tool that might be. So that at least it's sometimes easier just if you see it. So let's quickly see if I can. I have a graph too now, so this is interesting way I graph it together. So I'm just quickly showing you. So obviously, this is, they do it as two graphs, which is probably not correct. So probably need to find a better graphing tool. Let's see if I see it doesn't change. So you can see obviously that is the one graph. This is the other one, but it should be one graph. So I will get you guys a better tool that one can look at, because again, one just want to get a view of how the graph looks like, so that it, when you need to start working out areas, at least you have a view of it. I will share a graphing tool on the WhatsApp group as well. So I will definitely do that for you guys, so that you can just, I think it's always good when one practice these things, just to have a visual of it. And then later on you will nearly get used to the different formulas. So this would look something like this on a graphing tool. It should be more like that. So it should have been that these two nearly connect with one another. So that is why I rather get a tool that really does join the two functions and not have it as two separates. Okay, so that was chapter 7, where we looked at integration. We looked at, there's a few rules with integration. I'm making a note so that I just share with you guys also my summary. I've created some summary pages that nearly summarizes all the things that you guys need to know about this, not just integration, all the study units. So I will share that over the weekend on the WhatsApp group as well. Just so that you again see what's the rules with differentiation, what's the rules with integration, and some of those links. Okay, then we go into nearly the application of differentiation. So again, very similar to things we did in study unit 6, where we said we sorry, not differentiation, integration. Chapter 6 was application of differentiation. So integration, so in chapter 6 we did differentiation, where we looked at some of the, remember, the average curves, the marginal curves. So now what we're going to do is we're gonna find your total revenue curves and your cost functions, but we're gonna get it from your marginal cost and your other cost functions. So now we doing the opposite that we did in study unit 6. So study unit 6, we had the total cost function. We differentiated to get to your marginal cost function, and then we divide it by quantity to get your averages. Now we're going to be given a marginal revenue function, and we will need to integrate that to get to your total cost function. Okay, so we again, and that's why I nearly like that one graph or one diagram. So what we are now going to do is we're going to do the opposite. So very important, nearly every time, the link between chapter 6 or chapter 5 and chapter 7, and the link between chapter 6 and chapter 8. And what makes it sometimes difficult is that you now will be confronted with a marginal revenue curve, and nearly the link again. Okay, but if I integrate the marginal revenue curve, then I get my total cost. So it's just again realizing that you need to now nearly work backwards in the process. So we're going to do that with this study unit. We're going to apply integration to find total revenue, total cost. Then also what we will be doing is try to get to a total quantity. So they might talk about rate of change in the quantity. So we will look at that. So that is again where we nearly would have seen in study unit 6, where we looked at averages, and now we need to basically work backwards from where we would have gotten to averages, kind of, because that would have been a change in quantity. So we will now need to move back from changing quantity to your marginal curve to your total curve. So that is nearly also a process that we will follow. So both of these nearly is a repeat of chapter 6. We just do the opposite. And then the last one is where we're gonna look at consumer surplus. So a lot of the things that we did with the area, and that's the words that I was looking for: consumer surplus, producer surplus, and total surplus. So this, as we did in study unit 5, 6, we looked at the consumer surplus, or not 5, 6, 3, 4, because it was linear lines. We did the linear lines for consumer surplus and producer surplus. Now we're gonna do producer surplus and for curved lines. Okay, but the process that we're gonna do for this is the same when we worked out area. Okay, so we're gonna do exactly the same. We just need to make very sure when we work with lines that we know what the points is that we want to work with. Because that again, when we integrate and we're going to say between certain points, that is going to work out the area for us. Okay, so nearly the application of that area is we're going to work out consumer surplus, producer surplus, and those kind of things. Okay, so that is nearly when we look at what we will do in this study unit. So this is also the last study unit of this DSC program. So basically, and again, it's nearly to remember the process. So we work from total cost to marginal cost to average cost. In that process, we differentiated. Now we're going to move backwards and say we're going to move from marginal to total. So what do we need to do? We need to integrate. So one can get, again, and let's say your more complex, where if we divide by a number, we need to work with ln or log. We might get a very simpler one that we don't need to work with logs or exponentials. We just rewrite it into the integrated formula. So again, with nearly the three things that will be important in this is that you will be able to work with the exponential, need to work with ln or log, and then your normal straightforward one or two terms that's got a x that we just nearly repurpose into a formula. Okay, so sorry, so that is nearly the three components that's going to be important when we move from marginal to total cost. So let's quickly look at this one. So what we needed to do was, so you can decide again, because this you probably will write out on paper as you work it out. You can decide to what extreme you want to nearly calculate and write. So you could have write down what we would have said. So marginal cost is nearly total cost, but differentiated over Q. And then they would have given us, okay, so that was a given. So again, they need to give us at least some form of the formula. They can't just tell us you need to work it out. So that will be normally, and you will see here that was the formula that we needed to work with. So they need to give us at least the the formulas that we need to work with. But this component you didn't need to write down. So again, you can nearly decide when you work with this, what's the easiest and what is the minimum of information that you need to write down to get to your answer. So we will need to work out total cost. Total cost is when your marginal cost DQ. So out of this one, we can then see your marginal cost is the 10 over Q DQ. So again, look at that. So you could have said, to make it easier to see, 1 over or 10 times, and that is just sometimes easier to see. So you could have said, okay, 10 times 1 over Q, so that you can see 1 over Q is ln of Q. Okay, the 10 will be there, and again, add the C, but nobody's going to look at it as you work it out. So then probably will say, but you can leave out the C as well. And then they tell us that where Q is the number of units produced, it is also known that the total cost of producing 100 units is 500 Rand. Okay, so now what actually we worked out is that C, sorry. So that, remember, and that is nearly where this now comes in your total cost. Total cost is a function of, we did it in chapter 3, variable cost plus fixed cost. So when we look at the cost functions, your C will actually be the fixed cost. And the reason also for that is it didn't matter how much variable cost there is, the C would have also, will always have been without any Q or anything like that. So in this instance, they want us to work out what that fixed cost is. So that for me is important also. I just thought I need to work out the one formula, but I forgot actually what it is that we need to fully work out. So also be just careful in a lot of these examples. Just check what you need to work out and don't make assumptions. I just thought I needed to work out this. And that's why I originally said, but leave out the C. But I'm not getting to, again, I went nearly to, with what I wanted to calculate is, and will erase it now, but I was thinking that I'm going to need to do this. And again, don't just assume. It might be later on that we do it, but again, that was, so I would have gotten this one totally wrong because I would have just been on the wrong path with this. So please, also when you read the questions, make nearly a note somewhere on a paper. So if you look at question say this was question 20, write down question 20, okay, I need to get to a total cost function. And then write down, so because then I would have, if I've done this, I would have actually seen that I need to work with a C and I'm not going to do the other things. So they told me I need to get to a total cost function. So my mind was just automatically where we were working with the others. I actually just went to area, not really what I needed to do. So write that down for you. Then you know that, okay, this is what's the process. So the 10 log to Q will be your variable cost, and then your fixed cost will be the C. They tell you in this instance what your C will be. So they can do it in two ways. They can physically tell you your fixed cost is 453.5 or 95. They could have done that. Or they can tell you, but when we produce 100 units at the cost of 500, that will be your fixed cost. So so we will substitute it in. So ln of 100. Now you will see what I did here with ln of 100. So again, that previous question, where I went and said it needs to be positive. So when you work with fixed cost and variable cost, this number, you see, we didn't put in any of the absolute numbers, but it can't be negative. You can't produce a negative quantity of units. So previously we put the absolute because that is in theory how it will look. But in practice, you actually can't produce negative. So you can't produce negative units. So that's why we didn't even put in here the absolute value, because it will always be positive. It can be 0, but that's fine. But it can never be negative because we can't produce anything negative. So again, I showed the absolute value, but that is just in theory, because when we use it for total cost functions, it can't be negative. So yeah, so I just wanted to make that one clear for you guys, why we didn't now put in the absolute signs, because again, specifically with the marginal cost, total cost, average cost functions, you just can't produce anything that's negative. So we will have now been able to calculate the C out of it, and then that will be your total cost function. What you guys also need to maybe check, so it might have been that they in your options they stopped at that point. So again, look at those two. So the only difference is what the value of C is. So again, just be careful when you do these problems. First, have a look at what your final answer is. Because again, if they could have given you all the information as is, but they could have kept it as C. Because they can't give you this option and this option. So it can be just one over other one. They can't give you both because both can be right. So just check if they have ended up with 4 options that includes the symbol C, then that is where you stop. If they don't include the symbol C and all of them have values, then you will need to work out what that value of C is. So again, just really let the answers guide you. Most likely when they give you information, you will need to use it. But again, we have seen in some examples, they give you so much information that you're definitely not always using all the information. Cool. So that was when we moved from marginal to total revenue or total function with a lin function. If you now look at one where we just have this, so again, this one is much simpler to evaluate or to put back into a total revenue function. So again, things that you will see here, we did total cost. Here we're doing total revenue, but it's the same principle that you will follow. You will work from your marginal revenue back to your total revenue. The previous one, you had your marginal cost that you work back to your total cost, and the same process. So you will add the Q. It was Q to 1, so divide it by 1. We don't need to add that component. Or Q over 2 or to a power of 2. So we will divide by 2, and then there's this C that we need to add. Then, yes, they give us a bit of information around that. So they tell us that where Q is the number of units sold and that total revenue from selling 25 units is 1,250. Okay, so we could have calculated C again by, let's just quickly simplify this. Okay, so that is total revenue. So we could have just said, okay, but they tell us the total revenue is 1,250, and then we need to substitute the 25 into this formula to calculate what C is. And in this instance, strangely enough, C was 0. So your final answer would have been total revenue is 100Q minus 2Q to a power of 2. Okay, so this is now a interesting one, because what they might do is have this as an option and be sneaky and have this as an option. Okay, just worst case scenario is that they can have that. And we've now nearly every time said that, remember, add the C to your equations. But now they've given us information to show that for this one, C is equal to 0. So it will be very sneaky if I do something like this in the exam. So please look if there was anything like this in any of your assignments, that could have been that they give you information and your C is actually 0, and then what options they give in your answer set. So this one I just mark as just be very careful. Um, it it will be unfortunate if I do something like this, because this is really very sneaky, because we are nearly programmed to do or add with C. So this would have been a very, very sneaky one if. So please just look at some of your previous assignment questions and just look at if there was one that you needed to both on um, from marginal cost to total cost, or from total revenue and marginal revenue. Just check for me if there was anything like that in any of your assignments, and that will just would be interesting to see if I've actually done it to that level. Okay, then rate of change, and rate of change again. I think the important thing here is we work rate of change exactly the same as looking at a formula and putting two values in. So again, it was easy when we did a line like that, because we could have said, well, we would have done, the slope would have been your rate of change. So again, with the non-linear functions, it's much more difficult to get the rate of change for this cubic function, or sorry, quadratic function. So much more difficult to get it for this. But we have learned out of, where was it? Study unit 5 or 4, I think, that if we get the slope, or if we get the line that touches this, we actually work out what the rate of change is. So what we need to do is differentiate the function. So that again is quite interesting. So we get the derivative of a function. So that is the slope. Your very similar to what we've done in a linear, where we would have said change in y over change in x. So what we will do now is to say, for, let's say, for your total cost function, there's your changes in the one. Remember, it is going to touch the, let's say that was the function. So because it's or touching that function, we will just need to work it out between 2 points, because that will then show us the change in that function. So it might be that, and I've now just made it to touch there, but it can actually move. So again, when we work it out, we will again need to work between points. So they need to tell us what is your rate of change between 0.5 and 0.1, or between 3 and 2, or 6 and 1, or again, it's not something that we could nearly guess. It was the same with linear functions. We would have needed to know what that x and y was, and what that x and y was, and then we would have been able to work out what that change is between the 2 points. Exactly the same with a non-linear function. They must give us information to work between the 2 points. So what they will need to do is to say to us, okay, is it that we work between, so here they set the example, at a small tool hire company, the estimate rate of increase in the maintenance cost of power drills is given by this function, where T is in weeks. So what they then said to us is, okay, but let's work out what the maintenance cost is during week 0 to 5. So you will see we use 0 or 0 to 5. The nice thing about the 0 is because we work with a T, that will nearly fall away. But again, you could, let's quickly get to that function. So 2T, so remember, we'll add the T, there it is plus T1 plus 1.5. And then we divide, let's just make sure, 1.5 years, and we will divide by 2.5. So we could have just changed that to 1 plus 1.5 would have given us 2.5. Okay, so we could have, again, we don't need to write down everything. If it is an easy one, you could have gotten it. So 2t plus t to a power of 2.5 divided by 2.5. So then we would need to put in 5 and 0. 0 will make it that 0 and that 0. So 0 will in the end cancel it out. But if I put in 5, it will be 2 times 5. That will be 5 to the power of 2.5 divided by 2.5. So when we work it out, we will get 32.36. So that is, and it would have been, again, I don't have the faintest idea how that curve will look like. So let's not put something like that in. So that would have been between 0 and 5. And then the other thing that they ask us is, so during the following 5 weeks, 5 to 10, what will be your total maintenance cost? Okay, so now we do exactly the same. We just substitute 10 and 5. So we already know what 5 is. That is 32.36. So we will need to work out what it is with 10. And in this instance, it was 146.49. So between weeks 5 and 10, the total maintenance cost would have been 114 Rand. So the first 5 weeks, total maintenance cost 32 Rand nearly. The next 5 weeks, it went up to 114. So again, something like that then would have been probably something like an exponential curve, because if it was a straight line curve, the next 5 weeks would have been exactly the same. So this is probably more something like exponential, because it does exponentially go up for the next few periods. Okay, so that is basically, and again, there will now be some other options that you can work through, because as always, we will do the one with E. We will do your normal one that you can work with. And normally there is one with log. So I will get you a log function as well, because there isn't one in the examples with log. But you can nearly now see the process. It's nearly every time between three types of equation. So your normal equation, like this one, where you will just integrate it to the higher power one, where we know exactly what to do. Or it might be that we work with a log function, or it might be that we work with the exponential function. So nearly all of the from study unit 5, 6, 7, 8, that is nearly the types of functions we will get every time. So please, again, when you practice and when you look at examples, if you don't find examples on one of those three, please let me know. I will look at previous exam papers also. If you guys have exam papers, please forward it to me as well. From next week, we basically will focus on exam papers. So please do that, because again, I want to make sure that we cover all the possible questions that they might be able to ask you guys. Okay, so then the last component nearly that we need to look at is consumer and producer surplus. So what we're gonna do with a consumer and producer surplus is basically we're gonna work out the areas. So this would have been one of where we have looked at exact market equilibrium of a linear function. That is work we've done in, what was it, chapter 4, I think, if I can remember correct. But what we are now going to do is work with nonlinear functions. So then we need to remember, okay, nonlinear function, we will need to get the area underneath a graph. To get to the area underneath a graph, we need to integrate that function. If we integrate that function, and now specifically this function, this is what we will get. But now remember, when we're going to work out this for points 8 to 0, what we're actually working out is that whole area underneath the function. Okay, so we're going to work out that whole area underneath a function, and that is not what we want for consumer surplus. What we want for consumer surplus is to find where they said market equilibrium is. Remember when we did it in the linear functions, they said, okay, there was market equilibrium. That was your consumer surplus. The red one was your producer surplus. Exactly the same principle applies with the nonlinear function. So the only thing that that's different is nearly there isn't a line like in the linear function where we knew demand and supply. So they will give us a point to say, well, there is my point of equilibrium. So that you guys will need to know, okay, but then at this point between 8 and 36, so that is then the area that I need to subtract. So I need to, and I normally do it just to show it. I need to subtract that square from that function, because that is the part that I need to take out. So that was the 36 times the 8. Okay, so when we do consumer surplus, just like we did with the linear equations, remember, we're only looking for that part above the equilibrium. So obviously then the opposite is also true. So when we look at producer surplus, remember there was that line, so that would have been your consumer surplus, that was your producer surplus. We will follow the same process with your producer surplus. So I'm quickly going through this, but just wanting to show that exactly the same process again. So you could have drawn in a line like that for yourself, just to make it visually more appealing, that you can see what you need to do. The top part is your consumer surplus. Now we need to work out what is your producer surplus. So again, the same process will apply here, is that you will work out your total. So you will work out this total area. So in this instance, it would have been the between the 4 and the 40. So here you would have done it for that area. So we could have, again, so just make sure this was the formula. So this was now not a straight line formula, also not cubic as in, I think this was, or not cubic, yeah, cubic. So not a cubic. Now we're working with exponential. So when we work with exponential, it changes a bit. So again, know the processes. So with consumer surplus and producer surplus in this chapter, again, there can be 3 ways to look at it. So the one was the normal one that we just had with cubic. Um, you could have the one with lin or log, and then like we do have here, your e function, your exponential function. So again, producer surplus and consumer surplus can be any 3 or any one of those 3. What, sorry, let me, what is most likely gonna happen is that you will get a consumer or a producer surplus for linear, which is normally straightforward, and you will get one consumer surplus that is based on one of these three, but normally also you will get a producer surplus that is based on one of these three and normally not the same. So just when you guys prepare, I will get you a few different examples of this, because again, very important nearly for me is that you look at the differences, so that one can nearly for each one. So what I will make sure is that for the exam prep, we will do a consumer and producer surplus for your linear. So that will be 2 questions that we will cover there. And then for consumer and producer surplus for all of the others. So there will be 6 questions that we will cover in that instance as well. Just that we cover everything for you guys. Then the last thing, and I think that is, so where they talk about really looking at consumer surplus and producer surplus. So where they nearly want you to do the total surplus. So I haven't really seen it in exams before. So that's why I have included it in the slides. But I must be honest, I haven't seen it in exams before. So again, if you guys have seen something like this in your assignments, please send me a copy of that. But total surplus is just you add the two together. So again, when we will work it out, we will need to work out the consumer surplus component. We will need to work out the producer surplus component. What it can also mean is that we work out what is the area underneath, and then we will need to work out, and you can see it in that part where what we will then nearly subtract is this component in red. So we can work out that full component with the first formula. We will work out the second component, that smaller one. So that is how we can work it out. So again, some different methods in when we need to work it out. So if it was a cubic, what we would have probably done is also work out the total and subtract that smaller area. But again, we needed to then have both equations, like in linear equation, we needed to have both equations to work out what my total, if I needed to work out the total surplus here, I needed to have both equations. So both the demand and supply. So again, for total surplus, again, I would need to have both total, the demand and the supply curves. If you work with consumer surplus, producer surplus, then you only need for one curve. If you work with what is for consumer surplus, again, you also only need to work with a one curve, because the second important point is equilibrium. So again, if we look at producer surplus, we work with a one curve. The second point is your equilibrium. So there's always the curve component plus that nearly square or rectangle, rectangle, depending on how it looks, that will be the second component. When we look at total cost or total surplus, we will need to have both. Okay, so again, then we will need to know what your demand curve is. We will need to know what your supply curve is, so that we can work out both of them, and then also to get rid of that smaller part of the equation. Okay, so that is nearly a quick run through chapter 6, 7, and 8. For me, what is the most important, nearly just for you guys to remember, and it is nearly that at the beginning of chapter 6, where was, I just want to quickly, so nearly looking at this curve or this table. So basically what this shows is, when we differentiate, we move from, and let's hear this and quickly just do a recap of this, because this is nearly for me the one that you can print and have somewhere put up, because when we differentiate, we move to these ones. So we will differentiate a total revenue to get to marginal revenue. Marginal revenue, we will divide by the quantity to get to your averages. So when we need to move from average to marginal, we will multiply by your quantity, and then to move from marginal to your total revenue, we will integrate. So this one for me is a very nice one, because to that side means you're going to differentiate, and then moving to this side, we're going to integrate. And that then makes it easier also when they talk in the exam and your assignments, but I think your assignments are done now. But when you look at what they talk in their exams, so that when you need to work out total revenue, it is nearly, okay, is it a simple formula that I have, or do they give me marginal revenue and I need to integrate to get to total revenue? The same if they say, work out your marginal cost. We've given total cost is this, so then you know differentiate to get to marginal cost. It could have been that they give you average cost, then you need to basically times by quantity to get to your marginal cost. So this table is one of those that I really like, because it does nearly bring chapter 6, 7, and 8 together in when we need to work with total cost, marginal cost, average cost, total revenue, marginal revenue, average revenue. So it really does bring those concepts together. Okay, so that is it for today. I will again share everything on WhatsApp. I'll share the recording. I'll share the this presentation, and then when you guys listen to this, also please start sending me examples. So if there is any examples that you had for this semester that was of your assignments, or as you go through external papers or other study material, please just pop that question onto a WhatsApp group. I will pull that question into into a presentation, and from next week, we will just work through examples. So from next week, we will just cover examples. So I've got a lot of examples that we can work through, but also if you guys have anything that you want me to focus on, please let me know, and we can structure the sessions like that. Okay, have a good Saturday, everyone. And if you start already with exams next week, good luck. But then we'll chat again next Saturday. Okay, cheers, everyone.